Everyone, it's Miss Craig again. We are now on to lesson 2 of the week of April 27th to May 1st. I hope you are all doing well. This is our Learn About It video on applying properties of similar triangles. So in lesson 1, we talked about similarities with all sorts of polygons. Today, we are just going to focus on similar triangles. So the first theorem we're going to talk about is the triangle proportionality theorem, which says that if we have a line that's parallel to the side of the triangle and it intersects across, we divide those sides proportionally. So here we know that XY is parallel to AC, and these little arrows kind of gives that away. So because of that, it now divides the sides proportionally. So B to X and X to A, so those are kind of the two pieces of the side BA that got cut by that parallel line, is then in proportion or cut in the same similar way if we take B to Y and then Y to C that was left over. And then we can use this theorem to then solve for missing pieces. So we would set up the proportion. We would then substitute in our values. We're going to use our cross products to get that missing side, similar how we did in lesson 1. So we are trying to find US. So the first thing we notice is that we're given that V to U and T to the S are parallel to each other. So now we know that the sides are now cut proportionally. So we know that means that U to S and its other piece that was cut, R to U, is in proportion to, on the other side, V to T. So if we go in the same order, to its larger piece, which would be R to V. Then we're going to go ahead and substitute our values. So U to S, we don't have any values, so that just stays U to S. R to U is 14. V to T is 4. R to V is 10. And now we can solve by using our cross products. So we have 10 times US, so we just have to keep it as US, equals 14 times 4, which is 56. We then divide both sides by 10, and that would give us US is equal to 5 6/10, or you could do it as the fraction 5 3/5. The next one, same thing. First, we need to notice if we have that parallel sides, and we do, P to Q is cutting the triangle and it's parallel to L to M. So that means we can use our idea of the triangle proportionality theorem. So we want to find PN. So we know that L to P and P to N. So from what it was cut, the little part and the big part. On the other side, we have to keep the same order. So we would say M to Q and then Q to N. So the little part and then the larger part. So now we're going to substitute in our values. So L to P is 3. P to N we don't know, so we're going to leave it as P to N. M to Q is 2. Q to N is 5. Then we can use our cross products. So 3 times 5 is 15, is equal to 2 times P to N Divide both sides by 2, and we're going to get P to N is equal to 7 5/10. So again, just like in the other one, the order is important. Now we're going to talk about the triangle bisector theorem, which is saying that the angle bisector, and we did this earlier in the year, so that angle bisector, remember bisector means you're cutting it into 2 equal pieces, divides the opposite side into 2 segments whose lengths are in proportion. So again, it's that idea of it's cutting it into proportion. So in here, if we did B to D and D to C, so AD is what cut it. And then we have A to B in the same order is then in proportion to A to C. And then we can solve. So we would use the idea of the bisector to set up our proportion, substitute in our values, use cross products to solve for that missing side, just like we did with the triangle proportionality theorem. All right, so we have our angle bisector. So again, we can set up RT is then proportion to the other side, TS. So we were on the left side triangle, so that means we're going to stay on the left. So now we have Q to R, keep in the same order, Q to S. We're going to substitute in our values. So RT, we don't know. TS is 8. QR is 6. QS is 9. We'll go ahead and use our cross products to solve. So we have 9 times RT is equal to 6 times 8 is 48. Divide both sides by 9, and we get RT is equal to 48/9. We could simplify by 3 and get 16/3. If you want to turn it into its decimal, it would be 5 3/10. Repeating. Same thing. We could see that it's a bisector because we've got those equal angles. So we're going to set up our proportion. So we can set up, if we go M to N, and then N to P. We go L to M. Keep the one on the left, same order on the right, L to P. Fill in our values, so M to N is 4, N to P is 3, L to M is 5, LP we don't know. Use our cross products. So we have 4 times L to P is equal to 3 times 5 is 15. Solve for LP, divide both sides by 4, and we get LP is equal to, we can leave it as 15/4, or we could change it into its decimal 3 75/100. Next, we're going to go on to the triad to practice using the triangle proportionality theorem and the angle bisector theorem. There'll be another video. If you're in my class, you'll also do activity 2, and then eventually the show what you know. Hope you are all well. Take care, and we'll talk soon.